Have you been wanting to learn how to create inlays with your CNC router? Then you've come to the right video, because I am going to teach you exactly how to do inlays from the beginning to the very end, and I'm going to take you step by step through the entire process. And by the time you're done, you will watch your own amazing inlay CNC router project come to life, just like you're watching here. You're going to learn actually how easy it is to create an inlay and how perfect you can get them so long as you follow a few simple, specific steps, which you are going to get in this video. What I'm going to do with you is we are going to find the design, in this case the feather, and then we're going to actually design up the inlay for the insert and for the base piece, and then we're going to run out toolpaths, and then you and I are going to run it out on our long mill CNC router. I'm going to teach you how to take two raw pieces of lumber, a piece of oak and a piece of walnut, and I'm going to show you how to set them up on the router and then carve out the female part and the base piece, the male part, and I'm going to show you how to get these guys together, if I can just get them to match up properly. There we go, just like that. And then we're going to finish it up into a perfect inlay. I want you to take a look at how perfect this inlay really is. It almost looks like the same piece of wood, just stained. But I can prove to you that it's not, because I've got more of them. And another one. There you go. Look at that. And look how perfect all these inlays are. And you're about to know exactly how to do this. In fact, I'm going to give you this inlay file. I'll give you the design file, the picture of the feather, and I'm going to give you the G-code, so if you follow the setup instructions, all you have to do is just create the project. The link is down below if you want to follow along with me. So what we're going to do is get on the computer now. We're going to run through the whole design concept, and then we're going to get onto our long mill, and we're going to create this amazing project. Let's get going. Okay, we are in the Vectric software. Now, I just want to let you know that the majority of softwares out there, you can do this with, even the freebies, if you finesse them the right way. Just follow what I do here to the T, and you will have an amazing inlay project in a very short period of time. And I want to tell you this, they are easy to do once you get it down. So the first thing we want to do is determine the project that we want to do. So this will be the first step. We're going to get the bitmap that we want to create and turn into an inlay, and then we're going to design it up. And we're going to do the male and the female designs first, then we're going to worry about toolpaths. So the first thing is the design, the bitmap. When we go to Google Images, as you know, you can get all kinds of images. And one of the things I don't like to see people do is, let's just say you want to do the feather, and you want to start from scratch. And so you come to Google Images, and let's just say you like this one right here. And so you take a screenshot of it and then use it as your bitmap template. When you look down here, there's a price of $1.99. Somebody did some work to create this. Do them the favor and the honor and pay for it. If you don't, then basically you're taking from somebody, and we don't like to have things taken from us, and it's $1.99. Please be respectful that way. Let's take it from a different perspective. If you are wanting to earn an income with your CNC machine, and you're taking from people who are trying to earn an income with their CNC machine or their CNC related skills, that's not a good habit to be in. Somebody did work and they're trying to earn an income off of it. And eventually you'd want to be doing the same thing. So honor that person and make sure that if you use a vector that someone's trying to sell, that you pay for it instead of just doing a clip off the screen. Let's get back to this. Now what you can do is do what I do, and I will do a search in Google for free feather, DXF, PNG, image, whatever you want to do. And so I just did free feather PNG. Go to images, and I'll select the feather that I want to do. So you can do this in the same way. You can even do one as challenging as that. I might try that one next. That's kind of fun. Once you do this, it's not challenging at all. So we'll just grab this one here. We'll click that, and I just want to make sure that this is free. So it says PNG free. So I am happy with that. So what we're going to do is basically use our snipping tool. Now, if you don't know what a snipping tool is, you come down to the little white box here in the PC and start typing SNIP, snip, and your snipping tool should come up. Oh, it didn't take in the S, so SNIP. There we go. And there it is. You select that, and the snipping tool will launch. There it is, right here. And all you do is select New. Click that, and everything behind you will gray out behind this box here. But you look at my cursor, it's now a plus. What you can do is simply start a window and grab a window around that project, and now it has saved it. And now that we're there, we're going to select this here. It says copy. So you're copying it to the clipboard. You can also save it as a file and then import it. So now we're going to go over to Vectric, and we'll create a new job. And I know the job size I'm working with is 10 inches by 5.5 inches by 1.25 inches thick. And the material surface is where we're going to be working off of, and we want to be on center of the project, and use your standard resolution and click OK. Now we have our project. Now all you have to do is hit Control V, and there's your image, and you can create the bitmap out of that. Now, since I am going to make this feather available to you that I did, we're not going to use that. So now you know how to import one. Well, we're going to delete that just by hitting the delete button while it was selected. And now we're going to go to import bitmap. Up in file operations, it's this little folder with a little arrow coming out of it. Select that, and you will come into whatever directory, and you come into the directory that you want that has the image in it. So I selected that feather that I did, and now we want to trace vectors around it. So when you trace vectors around it, the image has to be selected. So if you see, if I click off to the side, this is grayed out a little bit. That means it's not selected. So when I just click over it, it's now selected. You see now it's kind of bold, and if you look carefully, you'll see a purple dotted line going around the image. That means the image is now ready to be traced. So we come over to Create Vectors, and down at the bottom there's a little folded airplane type of looking thing. It says Trace Bitmap. Select that. Now, one of the things I just want to point out, it's easiest to use images that have stark contrast. And what I mean by that is, I'm going to come back over here. You see it's black, black, black here, and white, white, white here. So this would create a good outline image. However, right down here it gets a little white. It'll still work, but you just have to make a few adjustments. So I just like to work with images that have nice stark contrast. If I close that out and I just look at some of these other ones, let's see something that does not have a stark contrast. Almost all these have a nice plain background to them. Like here you might have some difficulty with this yellow one because of the checkered background. Okay, so we are going to come back here, and we're simply going to make sure that we are selected on black and white, and we are going to go with the defaults that Vectric selects. So you see this slide bar here and here at the bottom. Vectric has defaulted to those. We can adjust those if we want, but because it's a very stark contrasting image, it'll come out quite nicely. Simply go down to the bottom and select Preview, and now you can see we have vectors around our image here, and we're going to click Apply and Close. So now we come up to the layers area right here, and when it turns blue, you click it with your mouse button and this box will open up, and you see there are two layers. There's a bitmap layer and a layer 1. When you imported the picture, it created a new layer called bitmap layer, and that's where the image is at. Well, we don't need the image anymore, so we're simply going to turn that off by clicking the little light bulb, and we want to make sure up here it says layer 1, and we are simply going to click off, and there is our feather, but we have to do a little bit of work to it. So we're going to doctor that up, and this is why we have to do work to it. You can see the border here is part of the feather. So if I clicked anywhere on the border right here, the feather is going to highlight as well. I don't want that to happen. I want to make the feather all one vector. So what I'm going to do is come over and grab the curve or draw arc. And I'm going to make sure my snaps are turned on. Both of these first two have to have boxes around them, and that means our snaps are on. And then I'm simply going to hover over that intersection point. Now you can see there's a little black dot showing up. That means that we are now referencing that, and we're just simply going to hover over it and click once, and now we have clicked right on that corner. And we're going to come over to the other corner and click on that, and then we're just going to make a little arc about like that. And you can see it's not clean totally, it's like doesn't flow smoothly, but considering the size of it, that this is a 10-inch piece, you'll never see that minor deviation, so we're not going to worry about that. And then we're going to do the same thing to each one of these. Grab each corner and create the arc, and up top, same thing there. And right here. And there we go. So now we close this, and we're going to grab our scissors right here, because we're going to snip out these things now. The software is now giving us the ability to cut away these areas that we don't want. So we're going to click in each one. We've gotten rid of those, and one more, and then we're going to escape, and then we're going to simply select that box and delete it. And there is our image. Now I select the feather, and just to make sure that everything is connected properly, I am going to come over to Edit Objects and select Join or Close Vectors with a Smooth Curve, and I'm going to select it several times. And we are done. So now we want to get the leaf rotated appropriately, so I'm going to click it twice, and these buttons come up around the leaf, and I'm going to grab this outer button right there. You can grab any of the four corners, and I'm going to rotate to about where I want it at, which is about right there. And then we want to center it on the project. So now we come over and click Align Selected Objects under Transform Objects. And we're going to align it to the job center, so we want to select this middle button. That'll move the whole project to the center of the whole, that'll move the whole drawing to the center of the project. And now you can see the feather is in position now. So we'll close that. And we are done with our base drawing. Now we have to make a really quick distinction here, just so you know the terms I'm using. We have two components that we are going to be designing up. We're going to design up the insert and the base piece where the insert gets inserted to. So we're going to call this the male component, and this is the female component. So what we're going to do is save this by clicking Save. And I am going to create a new folder called, we'll call this Feather Teach, for teaching you. because you're going to create this awesome project. So we have a male and a female that we have to create, and we just simply need to decide which one we're going to create first. It doesn't really matter. This one will be the female, so we're going to call it feather female. And we're going to say OK. So now we just saved that vector file. So now we have to create the male file. And so simply what we're going to do is come up to File and Save As. And we're going to call it male feather. And save that. So we are at a critical point right now. And that is because you can no longer change anything about these files other than what I show you here. If you do, like change the size of the projects, then they aren't going to work together and you'll be wasting your time from here on out. So the feather sizes have to remain the same. Let's keep going. Now we have to create the mirrored copy. And what we're simply going to do is select the male feather, and this is where things become very important. In order for this thing to fit into the female feather, we have to create the mirror. And the way we do that is come over to Transform Objects, and the fourth icon in will say Mirror Selected Objects. Select that, and we want to make sure that we are checked on Flip About Job Center, and we do not want Create a Mirrored Copy checked. If we do that, then a second feather will show up as a mirrored copy and the original will stay in place. And we are going to click Flip Horizontal. And now we have the male feather as a mirror. So we are good to go with that. So we're going to close that. We're just going to save this real quick. And now our base male feather is created. So what we need to do is create some clearance space so that this feather can slip down into the female. One of the things that is commonly taught all the way across the board in all inlay videos I've seen, they come in and they will draw a square. That's the size of the project. So let's just pretend this is the size of the project there, and they'll draw a square that big. And the reason being is because you want to clear out all this material so you can overlay this part into the inlay. And so you need to remove all the material around it. Now, I happen to think that that is a bit of an overkill because you have to machine out all this material in order to make that happen. Whereas what I like to do is simply cut some of the material around the feather and then take a scroll saw or my table saw and cut away all the material up into the clearance area. So you'll see what I mean about the clearance area. But just leave it to this, that this is taking up a lot of extra machining time to accomplish what most people are teaching. So I'm going to teach you a faster little trick. So we're going to delete that rectangle. We're going to select the feather, and we're going to come down to Offset and Layout and select the first item, which is Offset Selected Vectors. Click that, and make sure you are clicked on outwards or right, and pick your offset to be between half of an inch to 3/4 of an inch, and I am set at 3/4 of an inch, and we're going to offset. Click the offset button, and now you see there is a general shape of the feather. So now all we have to do is clear out this space instead of all of this space here. So this part is done. We are ready to machine it. So we're first going to save. Click that. And then we're going to click this blue button right up here. So click this blue button, and that'll turn off the CAD or the drawing area, and it'll turn on the toolpath area. So now we are ready to do our tool paths for both our male and our female. But there's something I want you to understand before we get started. So we're going to switch over to another drawing. And so this is effectively what our project would look like if we took a cross section from it somewhere. This one here is the male component, or what we're getting ready to do the tool path for now. And this one here is the female component, where the feather will inset into it. So this is oak, this is walnut. Now when we put a inlay into a project, the one thing we don't want is for the bottom of the project to be flush with the inlay like that, because there's no place for the glue to go. There may be some slight deviation on the side walls of the project that may create some gaps. So we're going to set up some tool paths. So what we have is we are actually contacting the side wall here and over here before the bottom makes contact and before the top makes contact. That way we will have a nice flush contact all the way around, and we'll be able to clamp the top piece down to the bottom piece, and there will be no gap in our inlay. So in order to do that, we have to use particular settings for this. And so from here on out, you should probably take some notes into how we're going to be doing these tool paths. The toolpath information I'm going to be giving you for the male section and the female section are super important, and they work. I don't want you reinventing the wheel. So write down the toolpath information that I'm going to be giving you as we do this. I will also have it written down in the description. And I may even have a download link down below where you can just download a form that has that information for you. Let's keep going. The numbers I'm going to give you, I want you to always use. Don't try to reinvent the wheel. They work for many people. You've probably watched a lot of videos of inlays, or at least a few, and people use some random toolpath numbers. I want you to use these numbers and trust that they will work as we go along. Okay, so the first thing to know is when we look at this, because we are tapered, we're going to use a V-carving toolpath to carve both of these projects out. So we're going to switch over to the male, the flower. This is the feather. This is going to insert into the project core piece, which will be the piece of oak. And this is going to be the walnut. So really all is going to be left is the shape of the flower when everything is cut away. However, we have a piece of wood, and we've already created this boundary, and we have this boundary because we need to create a V-carve, and we are going to V-carve between this boundary and this boundary. So all this will be V-carved. Now if you've done any V-carve work before, you know that the bit will go all the way down until it creates a V in the middle. In this case, with such a wide area, which is something that we want, that V-carve would be really deep. So we are not going to go all the way down. We're going to use a special feature in Vectric called flat depth. Now, you will find this in the majority of your paid softwares, and I don't think you'll find them in the freebie softwares like Carbide Create or Easel. However, you can manipulate those softwares to make this work. Also, maybe I'll do a video on that sometime later. Anyway, so we want a V-carve right in here all the way around the feather. So we are going to use the V-carve toolpath. Now again, remember this is the male, and we are going to use very specific numbers here. Our start depth needs to be 0.09. Use that number as your start depth. Then you're going to check the flat depth box. We don't want to get this V all the way down, so we want to stop that at some point. And that's what flat depth does. It stops the V-carving at some depth. And we're going to set that depth to 0.02. And what this will do is this will allow us to have a 0.02 gap right here and right here, which means these two walls are going to make contact. And that's exactly what we want. We need a place for the glue to ooze out from these two contact points. So this will leave a gap underneath for the glue to settle in here, and it'll leave gaps over here and over here for the glue to ooze out. So these numbers are very important. Please do not reinvent the wheel and try to use a different number. These work. They've worked across the board. Despite any other YouTube videos you have seen where people use different numbers, these numbers work very, very well. So please use them. The next is the bit itself. Now, for average size projects like this feather, I like to use the 90-degree V-bit. So we are going to select that. The bit I'm going to use is the 90 by 1/4 with a bladed edge on it. It's an actual cutting edge as opposed to a flat edge. Here's the difference between the two. This is a flat edge V-bit. You can see that this is the cutting blade right here, and as it spins around, it's literally scraping the wood away. Whereas the bladed V-bit actually has a forward cutting knife edge on it. It's considered a knife V-bit. And these leave a much cleaner cut. So this is the one we will be using, 90-degree by 1/4 inch diameter. I use that because it leaves a much cleaner cut around the project. So it's a 90 by 1/4 inch, and we're going to select that. Now, because we have a flat depth here, as we are set up right now, the 90-degree V-bit is going to try to clear all that out with a point. So that's a lot of space to clear out with a point. We don't want to take that time. It'll take a long time. So we're going to use the clearance tool feature. So you want to check the clearance tool box right there. And you notice that this box now has turned white, which means now we can insert something. The bit I'm going to use is a very aggressive bit, which is an upcut bit. It's a 1/8 end mill. Now I'm just going to select my end mill here as a 1/8. This is my general end mill 1/8, and we're going to change the settings in just a moment. I'm going to hit select, and now we have the 1/8 bit. So we're not going to use a down cutting bit. We don't need to. We're going to be doing a V-carve, which means this side and this side are boundary, this boundary and this boundary are going to be V-carved. The clearance tool is simply going to clear away the material around the V area just to make things a lot faster. So an upcut bit, there's two reasons why we're using this in an inlay. Number one is the edges don't matter. If you know upcuts, it will tear the upper edge of your project, but in this case it's not going to matter because we're coming back across it with a V-bit that's going to clear all that away. And the second is an upcut bit can be much more aggressive than the down cutting bit. So I will show you the bit that I am using. It's one that I sell in the IDC Woodcraft store. It's also made for drilling. So I've had it designed specifically for this type of work where you can get very aggressive. Now the thing with the 1/8 bit that's going to be different here is we don't care about the finish of this surface. It's going to be cut away when all said and done. We're simply going to have the feather left behind. So that allows us to be a lot more aggressive with the bit. And we can have a much larger step over. So in order to get really aggressive with this, if you want to do like production work, do what I do and use the 1/8 upcutting bit, or even bigger if you want to, but use your high feed rates with an upcut. So I'm going to change that. I'm going to go to edit, And right now, that 1/8 bit is set for my typical 1/8 down cutter, which is 60 inches per minute. I'm going to change that to 80 inches per minute, and I want to make sure I get my depth of cut right. So I know for right now that I have a certain depth I need to go to, and that is 0.11. I want it to exceed 0.11, and you'll understand why in just a little while. So what we're doing is we're going to make that 1.125, which is what you can do with a upcutting bit anyway, is you can bring that depth of cut up to the diameter of the bit, or even 1.5 times the diameter. So we got a very aggressive cut, and we're going with a 60% step over, because I don't care about the finish. I'll even go to a 70% step over. I don't want to exceed 70. And we're going to click OK. And now that is set up. And now we're all set up. I'm going to refresh or rehash this. When you're doing the male insert, you do this in a Vcarve. Your start depth will be 0.09. You will have your flat depth checked, and that will be set at 0.02. We're going to use a 90-degree V-bit. Use a 90 for your average size projects. If you go to small inlays, you'll want to use a 60. If you go to large inlays, use a 120. All these bits are available on the IDC Woodcraft store, and links for everything that I talk about is down below, including getting this file. I will give you the G-code file. So we're using a 1/8 upcutting aggressive bit at a very high feed rate just to get material out of the way, and we're going to go with the offset cutting method rather than the raster. Climb or conventional doesn't matter. And we are simply going to give this a name. We're going to call it feather male, and we are going to calculate. And I didn't select the vectors, so we'll select the vectors and then we'll calculate. And now there are our tool paths. So the broad tool paths out here are the 1/8 bit, and the paths up in here, all these dark areas, are the 90-degree V-bit, and the 90-degree V-bit will also come across this line, this tool path, and probably this tool path as well, and it'll do the outer tool path, thus creating a V-carve type of effect, or a tapered feather that will insert into a tapered female feather. Alright, so with that, we'll just preview it. So I'm going to preview all tool paths. And there's our feather. Now you can see we have tapers all the way around the feather. And we have a taper out here. It doesn't matter out here, it's just by the nature of the V-carving tool path that it's going to look for an inner and an outer boundary, and it's going to cut them both. So even though it's going to cut that, it's irrelevant. This is what's important. Now, one of the things we're going to do is we are going to name our tool paths. We used a clearance tool and a finishing V-bit. So the first tool path here is our clearance tool, and that's a 1/8 bit. So what we're going to do is we're going to right click that first one. We're going to rename it to, let's see, feather male 1/8 UC. That stands for upcut. And we're going to put a 1 after female feather male. We're going to put a 1 in there. And the reason is because that's telling us that's the first program to run. You'll understand this in a second. In the second one, we're going to rename it feather male 2 90V. So now we've got that complete. I'm going to close that, and we're going to save the tool path using this button right here. So we click that, and we want to save all the visible tool paths, and we are going to come down to the word tool paths, the checkbox next to it, and we're going to select that checkbox. And now you can see these two checkboxes are selected. That's what this button does. It does a global selection of all the tool paths down here. With the visible tool paths to multiple files. You want to make sure your post processor is set up. I am using the Gerbil inch post processor for the long mill CNC router, which works just fine. And then we're going to save our toolpaths. And I'm going to create so I have the directory, I've already created it, we're calling it Feather Teach. So you see down here it says Feather Mail 1 1/8 UC. What I want to do is delete the Feather Mail 1. We'll leave the Feather Mail, but delete everything else. And then we're going to click Save. And now when I open up that directory, let's see if we can find it. We're going to go to the Feather. There it is, Feather Teach. And we have 2 G-codes written for the mail, and it's titled Feather Mail 1, Feather Mail, and it says 1 again, 1/8 UC. The second one, it says Feather Mail 2. So what Vectric has done was, based on the order of toolpaths over here, it put a 1 or a 2 in it. So we know now that this is the first one to run and this is the second one to run, and by the file name we know that's the 1/8 upcut end mill, and this one is a 90-degree V-bit. So we're going to stop with that one. We're going to close this and we're going to save this file. Save. We're done with the mail aspect of this as far as the design goes and generating a toolpath. Now it's time to get on to the female. Just remember, the settings that we're using are very specific, so please keep note of that, and they are listed down below with the female settings that you'll need. Let's go on to the female. And now we're going to open up the female. So I'm going to go back to that directory, and we want to open up female feather. So I'm going to double click that. And there it is. So this is our project piece, the entire piece of oak, and all we're going to do is cut out the feather inside of here. Now, just want to show you what we have. I'm going to come over to the mail, and I'm going to switch back over to the 2D view, and I'm going to turn these lines off. By the way, these little lines that you see, these are the tool paths, the actual paths and direction that the bit is going to go. So in order to turn that off, you come up to this area up in here where you have all these icons. And there's going to be one that's just going to be highlighted with a little blue line. Select that and that'll turn that off. So this is the male feather, if you remember. I'm going to click that and I'm going to Control V or copy it. I'm sorry, Control C. I'm going to Control C and copy, and then I'm going to go over to the female. And I'm just going to go Control V. And that pastes it over. Now you see it's a mirror image of that feather. So this one is the female. This one is the male we just created. And I just want you to see that they are duplicated, but they're reversed. So I'm going to delete that one because we don't want it. And now we're going to generate the tool path for the female feather. So we're going to come up here and click this blue button. Bring in the toolpath area. We're going to select that. So we're going to go into the Vcarve toolpath, select that, and we are going to have the numbers in there that we had when we entered into the mail. We don't want those numbers. Our start depth for a female, write this down, female is a Vcarve, and the start depth is 0. The flat depth will be a 0.11. For the female section of the Vcarve, your start depth is 0, have your flat depth checked, and that flat depth is 0.11. We want to make sure we're using the same bit, which is the 90, and that's fine. Now I'm going to take a look at my feed rates just to see what we got. I've got a 70 feed rate, which is just fine. So we're just going to cancel that and leave it at that. We're going to use the same 1/8 end mill, so we want to use our clearance tools, so make sure that's checked, and we have the end mill. It's the upcutting end mill that's suitable for aggressive work and for drilling. And again, we don't care about the edges that it creates because the 90 V-bit is going to come back in behind it and clear up any chip up that it has. And we want to check our feed rate. So we're going to go to edit, and I want to make sure we are up there, and our feed rate is in, for some reason I have 0.125 in there. I want my feed rate to be 80. And I'm going to say OK. And there we go. So everything is set there now, all the original settings there, and we are simply going to change the name. We're going to call it feather female and calculate. And so there is our female. We are going to preview all selected toolpaths. And now you see we have the female with the tapers. So the male is going to drop right into that. So that's done with the exception of changing the name. So we're going to simply change the name of the first one, which is the roughing. We're going to call it female, feather female 18UC. And we're going to go to the second one. We're going to call it feather female. And that's going to be 90V. And we'll just enter. We're going to close that. We're going to go to the save, click that, come down to our toolpath, check that white box next to it, make sure we are set up on visible toolpaths to multiple files. Your post processor is set to what you want. For the long mill, it's Gerbil, and we save selected toolpaths. And then we are going to simply take the bit out of the end of the name, and we're going to save. Now when we go back into that directory, we now have the female toolpath. And again, it's named at 1 with the 1/8 upcutting bit and 2 with the 90-degree V bit. So now our toolpaths are set. Now we have to set up the machine. We are ready to take this to the next step. Well, that's it. We've done with the design. Now it's time to throw it onto our long mill. We get to start making this. I was actually really pleasantly surprised that the long mill did this. I did not expect this to be as clean and sharp and crisp as it actually turned out. So getting that machine pleasantly surprised me on this one. I've had a lot of fun making these. But before we throw this on the long mill to get these things made, we have to deal with our raw material. So we're going to do that. And then I'm going to show you how to set up on the CNC router to get these things done. Easy way. Let's get going. So now we have 2 pieces of lumber to work with. We have our oak base piece, which we need to measure out, which is 10 inches long. And we need to cut our walnut, so that's going to need to be 10 inches long as well. So we'll throw it on the miter saw. And to make sure the saw is square. I want to try to avoid a step in the middle of the material, although it doesn't really matter if you have a little bit of a step in the material. The walnut, we're going to cut it in half because when you do an inlay, it does not need to be very thick. You can do it with a 1/4 inch piece of material because we are only going to make this thing a 0.11 deep. So you can do it with even thinner material, 0.2 thick. I'm going to adjust the saw blade so it doesn't cut all the way up. I only need to cut to the existing cut. I had to be really careful and aware where the saw blade was as I was moving that through. So now we have our board cut, and you can see right here we've got a little bit of a step. That's inconsequential because this is like the bottom of the insert. It's going to be inside the base material. This side is technically the top. Now what we're going to do is sand it down and get all the rough spots off of it, because we need to do this for the best holding that we're going to be using, which I'll show you in just a minute. Let's get the sawdust off of it. We're going to be using the tape and CA glue method. And so we have to get all the sawdust off to have as much stickiness as we can have with the tape. So what we need is our base piece, and then we need a little scraper, some painter's tape, some thin CA glue. Now this is made by Starbond, and I have a 10% discount code on this if you want. And then we're going to need the accelerator that'll accelerate the setting of the super glue. You'll understand this in just a moment. Now when you're using this method, what you do is you'll apply painter's tape to your project piece. Now I am putting 3 strips down. In this case we really didn't need 3 strips. We only needed 2 because there's not a lot of force being applied against the project itself by the router bit. So after you get it on there, make sure you take your scraper and just press it all down so you get as much contact area as possible. And you see I've got a couple gaps there, no big deal. Now what we're going to do is take advantage of our spoil board grid line, and we're going to put the mating tape on the router spoil board. That'll keep everything in line with the board. Then when we're done with that, we're going to take our scraper again and press the tape down all the way around. So now we've got a very good contact. And you see I even got a little bit of a gap here. That's okay. It kind of mates the gap on the board. Doesn't really matter. But now we take our Starbond CA glue, and we're just going to run a bead down each piece of tape about the length of our board that we're going to be cutting. You see there's the bead, and then what we're going to do is get ready to set the board on, because when we spray the accelerator on, this is going to accelerate quite quickly in the curing of the glue. And I slipped a little bit when I was doing that. Once you get it in line, just hold it for about 5 to 10 seconds and you'll be set. Once it's set, then we got to bring the router over and start getting our bit in. This is the platform we're going to be using to run our long mill. This is called GSender, and GSender is the one I prefer. It's very nice layout, easy to work with, and it's always being worked on, and it's free for anybody that has a CNC router. It's not just for the long mill CNC router, for any CNC router that has the Arduino based platform. Don't worry, your router has the Arduino based platform. I highly recommend the software. You can download it from the long mill website. They are actively working on it all the time for the entire CNC community. So there's a link down below to be able to get that and install it on your computer. All right. So the first thing that we're going to be doing is zeroing out our bit, which we're going to use these buttons here, X and Y, to zero things out once we get things in position, and then we're going to use the touch probe here. I will make another video about the touch probe features and how they're being used, so I won't run through that in here. However, I will run through the program loading for this project. So we're going to get our bit set up, and then we're going to load the first program. So we bring the router forward, and we're going to remove what we have in there, which is the surfacing bit. We'll get back to the surfacing bit later because we're going to need it to wrap up this project on the CNC router. So whenever you take your bit out, take your nut, your collet apart, clean it out with a toothbrush, get the sawdust out of there, because that sawdust will create problems for you later on if you don't do that. So once you get it loosened up, just blow it out. And the first bit we're going to be working with is the 1/8 upcut bit. And this is it. This is one I sell on the IDC Woodcraft store. Now you can see this spiral is very aggressive going upward. It's meant to take out a lot of material very fast, and it's designed to drill. Now we use a 1/4 to 1/8 reducing collet, and you're going to insert that bit all the way to the flutes into the collet. We're looking for as much support from the router as possible, and then you insert the collet up until it's flush with the nut, and give it a little extra tightening because we're using a collet in a collet. Now you see I've only got about 1/4 of an inch sticking out. So we're going to put a little cross mark on our board. We don't need to find a critical XY 0 point on this, because we actually have quite a bit of extra material. And then we're going to bring the bit over and just eyeball it over that crosshair that we just created. And we'll zero our X and Y once we get it in position. Now we're going to use the touch plate. Now long mill comes with this touch plate. You have to order it as an add-on. But this is very rapid in getting your router bit set up, much better than the paper method. So you bring the bit relatively close, maybe within 1/4 inch of the touch plate. And make sure your magnet is attached, because that's needed to be there. And then start the zeroing cycle. And the bit will come down. It'll touch the plate to get its first reference. And then it'll come down a second time to get a final reference, and we are good to go. Alright, now we are ready to go. We have our bits zeroed out, and we are now going to load our first program, which is the male #1 with the 1/8 upcutting bit. So we're going to come down here to the load file, select that, and we're going to go to the directory Feather Teach, and we are looking for the feather male 1 with the 1/8 upcut, and that's it right there. So we're going to select that, and it's going to load up into the software, and there it is. There's our runaround. So with that, we are simply going to turn the router on, and we are going to hit the start job button, and we're off. So the first thing this thing is doing is cutting out the outer outline of the feather. Now look how fast this 1/8 bit is traveling. This is why I use an upcut on this. We'll just speed things up. This gets interesting. This is where the real fun begins, and you are going to so much love doing this when you finally get to this point. Because what's really interesting is how fast every cycle runs. This is at 80 inches per minute. And we're cutting a 0.11 deep. So now it's cutting in some of the detail of the feather. And now it's going back and forth and touching a few points. It's kind of interesting that the software will do this. And it's not always very efficient when it comes around and cleans up these points like that. But we don't care about the surface finish here. So we're done. And you can see I got a lot of burr on there. We got the core shape of our feather going on. And now we're going to switch over to the bladed 90-degree V-bit. Now remember, all these bits I have available on my store. This one has that blade on it. It's going to cut things quite better than a flat blade will. So we're going to insert it about halfway in. We want most of that bit up in there. Get as much rigidity out of it as we can. So I'm just going to sand off the burrs off the top briefly so I can use the touch plate again, because they'll get in the way. Our XY is already set, so all we have to do is just set our Z with the bit change. And if you're wondering about bit changes, this is exactly how you do it. Your X and Y is already set. Now you just have to set your Z. It's going to come down and touch, and then we're going to get back into GSender. Now that we're done with the first part of that program, this is where the real fun begins, when this feather completely takes shape. And it's so much fun watching these when they're running. So what we're going to do is come back to Load File, select it, and we're going to find the feather male number 2, which is right here, and it has the 90-degree V-bit. That's the bladed V-bit, which I absolutely recommend that you use over the flat bits. All right, so when that imports, you can see there's a dark line around that outside perimeter that we had. That bit is going to follow along that perimeter on the outside. It's going to V-carve the outside, an area we don't need, but that's okay. It doesn't take that long. And then it's going to go around inside the feather. It's going to follow the perimeter of the feather, and then it's going to do a lot of clear cut where the 1/8" bit couldn't get to. So when all is said and done, this will drop right in after we do some cleanup. So now all we have to do is hit the start button and run the job again. And here we go. And now we're running around, and you see it's cutting the profile on the outside. Now you start to understand why that burr doesn't matter and why you want an aggressive bit, especially if you can just make multiples of these things like I did. I mean, once you make one, it's kind of an addiction to do these inlays. So I hope you've downloaded this feather inlay program I've given you. Remember, I'm giving you the G-code, I'm giving you the instructions, and I'll give you the file. Now, you can see that the 90 is coming back in. It's cleaning up a bunch of messy little spots that the 1/8" end mill couldn't get to. So it's going to do a lot of bouncing around here and not very efficiently. This is probably the longest running program of the bunch, and I'm going to say it ran for about 5 minutes. But look at the feather coming to life already. This is the male insert. Now it's done. Literally, we take it off, and you'll find in just a minute that all we have to do is get the burrs off of it and insert it into the female part. And of course, now we have to separate it from the table, so I have to use a little stronger scraper. But now you see how strong the CA glue is, and what's so nice about it is you don't have to use clamps. Look at that feather. If you're not impressed by now, you should be. Give me a thumbs up if you're liking what you're seeing. So there it is. So now we're going to take it over to the scroll saw. Now, you can do this a number of ways. I just happen to have a scroll saw. You can take it onto your table saw and cut it out. You can cut it out with a jigsaw, sawzall, torch it out, whatever you want to do. There's many ways you can do it. But you see, we didn't waste a lot of time taking out all that other material that we really didn't need to bother our time with. We just cut what we needed to get the profile out. So that's why I recommend you doing that offset function that we used to design the male. And our male feather is almost complete. Now we're just going to clean it up. Now I use these little Dremel burrs. These things are great. They're little sanding burrs. They're not durable, but they're not expensive either. But these are little sanding discs, and they each come in different grit. So the black one is the lightest grit, and the brown one is the toughest grit. And you can just tell when you squeeze them what the grit is. I don't know, they have declaration, but I never worry about it. And we're just going to throw it into the Dremel. And I stopped using the little wrench on the Dremel. Pliers work just fine. And then what we do is we run around all the areas of the feather and start cleaning up all the little burrs that are hanging on it. And this will take you about 5 minutes to do. I do pay attention to making sure everything's out along the leaf profile where it's going to insert, so it does drop in nicely. Of course, we're going to fit it before we actually glue it in place. But you see this little sanding disc. It goes everywhere. There will be a link down below in the description. I got it off of Amazon. I highly recommend you get that. If you're going to be doing these inlays, then you'll want to get these little sanding brushes, whatever they call them. These things are great. They're disposable. Like I said, they don't last that long. It's already starting to wear out. I don't care. It's about 10 cents a piece. But this one's still good, so we don't need to change it yet. So now it's time to get onto the female component, or the base piece. So we need to vacuum everything up, sand the bottom of your block, and we need our CA glue set up again. Tape, thin CA glue, the scraper, and the accelerator. And we're going to tape the same way again. Everything's pressed down. We put our bead on. We did a quick spray with the accelerator, and we set it down. We held it for about 10 seconds. We're creating our little crosshair. It's going to be right on the feather, right there. And it is solidly in place. It is important to make sure you push it down, though. And now we have to go back to our 1/8 bit again. Again, I remind you, these are down in the description. I'll give you 2 of them in that collet. Our X and Y has to be reset because we changed our project piece. So we're just eyeballing it again. And then we're going to set our Z0 using the touch plate, which I totally recommend, and then we're going to start the project off. We have loaded up the female part of the roughing out program. So I was having a little difficulty with my camera here, so there were some issues going on that a little frustrating. But I tried to chop out the difficulties. What it would do, it would just freeze on me. So now what we're doing is we are doing the 90-degree V-bit. I didn't show you the tool change because you've seen enough of that. But you see the first pass is simply outlining the feather. And it's going nice and quick. This is why I use a bladed V-bit as opposed to a flat V-bit. And I wanted you to see the whole run just so you understand how fast this is. And it's just kind of cool to watch. I'm just going to come back in and start cleaning out all of its stuff. You see it's doing a lot of fine-tuned cutting now. And it's knocking out most of the burrs as well. Of course, we'll still have some cleanup to do in this thing, but that's okay. That's why we have the Dremel. Again, everything I'm talking about, there are links down below for this and for the file to do this, the G-code file. So basically all you have to do is follow the instructions, load, and go. So again, the 90's coming in and just cleaning some stuff up. So you are gotten to the point now where you see this really literally coming together and how cool that feather is looking. So imagine what project you can make. And the idea that you're going to have a free file to start with, that's pretty cool. I was definitely surprised that the long mill was able to hold the detail where I could get a perfect inlay. So now you see this feather is awesome. So we're going to get our Dremel and we're going to clean it up some more. And the brush is starting to wear out, so we are going to replace it. So you see how long it lasted, maybe 5 minutes. Still worth the purchase, especially when you're doing inlays. So now we're just going to fit the male into it for the very first time. And just slide it around. This is where it gets scary. Will it go in? Will it go in? Yes, and it fit like a glove. You can feel it when you drop it down. Look at the gap. It's so close. We have got it. The reason I did it while I was on the machine, just in case I had to do some more machine work to it. So now we're going to do our final work. Peel off all our stuff, throw it away, and clean off our area. Now, of course, you want to make sure your project piece is very clean when you glue it, because we don't want anything to push this thing out so you have any gaps. And so that's how we're going to put it together, but first we're going to glue it. Now I use Titebond, the interior exterior wood glue, Titebond 2. I'll have links for that too. I prefer exterior glues or the interior exterior because there's moisture in the air sometimes. So we're doing a final fit to make sure everything is good. And everything's seated all the way around. And we are going to fill this puppy up with glue. Be very generous because you want this thing to seat, and you want every bit of that taper to be glued along the full length of the base piece. So I make sure that every angle has plenty of glue on it along the entire surface. Some people use those little brushes to spread the glue. I think it's a waste of money. There we have it. You see how the glue is laid out. Everything is covered. And now we insert the male feather. And this is where the cool stuff starts to happen. We are so close at this point, and I hope that you're getting excited about inlays at this point, because I've taken you step by step by step by step. The thing is once you get this down, it's literally wham bam thank you ma'am. It is really easy to do this once you get your design and understand the flow. So now of course I'm going to clamp it, but I did make a mistake here that I didn't think about. I'm clamping directly on good lumber, oak, and so I left marks with the clamp. Now I'm checking it with the flashlight, just make sure everything's seated, and you can see that everything is seated very well, and the glue is oozing out, which is good. Of course, after the glue dried, we take it apart, and the fun, the final stages. Will it come out? This is where you get a little anxious. Did it work right? Did it work right? So I will take my table saw and set the fence just so the base project has maybe a 0.05 gap, roughly. Of course, we're dealing with a open saw blade here and a piece that does not have a base to it. The insert will drop down. So this is where a lot of safety needs to be taken into consideration, and so I was leaning very far away from this, particularly on the second side. I know that right now it is still going to be held in place by the glue because I'm not cutting through the entire feather, but I have my head leaning way to the left. You're going to watch this plug fall out and disappear. This is where it can get dangerous. This is why I'm leaning way out. I've been hit by pieces that the saw has thrown once. I was cutting steaks. Look at that. I was cutting steaks for tomato steaks, and one of those pieces hit me. So now we're going to take this out over to the router. One more time, we got to deal with the long mill. So let's clean up our surface, our project, and we're going to surface it again with the CA glue. All the same stuff. Now, this is a surfacing program I'm going to give you as well. Now we're going to use the 1-inch surfacing bit. This is a bit that I seem to have a hard time holding on to in the store. This sells out fast every time I put it on the store. And that takes me a while to get it. If you need a surfacing bit, you are going to need one, and you don't have one, you can get that one. So we're going to set that up. Now we're zeroing it off the base piece. And then I have to set my edge up. And I'm just eyeballing it. The surfacing program is quite a bit wider than this project here, so I left plenty of room for air cuts. But I started my program off wrong. And so you see I got a little cut where I didn't want it. So I had to rewrite it real quick. And this is where the fun begins. This is it. This is the moment you've been waiting for. And this is exactly what you're going to have when you do an inlay. If you follow these steps, look at this thing come to life. Now, do you want to go do an inlay or not? Look at that. That is so cool. And I want you to see how crisp it is. Now I have a little bit of a circle mark there and some streaks from my bit, but that's okay. We will sand all that out. Look at this. This is off the router, not sanded, raw. Look how sharp that works. So this video has given you the step-by-step how to do an inlay. And I hope you understand it. If you didn't, make sure you read the information down below, download this vector file, do what you're supposed to do with it, and the final, do what I say to do, and then you will have an inlay project. So the final thing is just a little T-slot. I'll even include that in the program. I will tell you how to do everything on this project. Of course, the final finishing. I appreciate you've been hanging around this video, but I know that you have been wanting to do an inlay, and now you know it's not that hard. It seems like a long video because I was teaching you all the steps that, just lots of little steps along the way. I want to make sure you have it. So what I like to do is I like to put a quick coat of polyurethane on it first. It just acts as a base to seal it. I use clear satin, fast drying, and then my second coat I will put like lacquer on, and I'll put on 3 coats of lacquer. And that seals everything up the rest of the way. I could probably just stay with the urethane. Lacquer gives it the shine. I'm not sure I'll stay with the urethane on this because I like the satin. You can get a lot of reflection out of it and not see the artwork.
And that, my CNC router brother or sister, is how you go from this, a couple raw pieces of wood, to this, to an amazing inlay. And I had no idea that the long mill CNC router was capable of doing this. If anything has sent home that this machine is capable, this project did. This is so cool. I want you to take a close-up look at this thing again. Let's take a look.
I want you to see how fine this stuff gets. Look at this. There's not an error on this. Remember, this file with the G-code, the drawing, all the instructions, and everything you need is down below in the description. All kinds of stuff down below. You got to get the machine. If you haven't gotten a CNC router, this is the one to get.
If you've learned something from this video and you are going to be making an inlay, give me a thumbs up, 2 of them if you can, and a comment down below, say I'm going to be making it. I really want to see you make this feather. The download is below. free to you. I want to see pictures of it, or whatever inlay that you do. I hope you have a great day, better tomorrow, and go get that file. I'm Garrett with IDC Woodcraft. Talk to you next time.